Hello and welcome to this Construct 3 demonstration on how to create a coloring book. So let me show you here what happens. You can select one of those colors and then you can click somewhere in the canvas here and then we'll fill up the parts like that. And you can even do some complex filling, like for example this background will go all the way around and fill it totally with the color of the pixels you select. This is done using scripting, and I'll show you now how that exactly works. So let's show the layout. The layout is actually pretty simple. Here are the color sprites. You can go and select where we'll pick up the colors. This is a drawing canvas, this one here, and above that drawing canvas is a sprite, and the sprite contains this, I don't know which fruit this is, and then in the event sheet some simple things happen really. On start of layout, what we do is we paste the object, the sprite, with effects on the drawing canvas, and then we just have to wait for a little while for the process to complete, and after that we just destroy the sprite. So actually we're just left with a drawing canvas on the layout plus a number of buttons. Here the select color, when we select one of those buttons, this color sprite, of course, we will be setting three variables: RGB, which is red, green and blue, of course, and we will extract these RGB values from the color sprite. And then there is also a frame. We set the frame to the position of the color sprite, so which is this frame here. It goes around and switches to the active color. Alright, let's put that back into place. But the bulk of the story, of course, is this on left mouse button click of the drawing canvas, where we will set an X and a Y also. And the X and the Y is whenever we click somewhere on the drawing canvas, we need to know exactly which pixel on the drawing canvas we are selecting. But if we were going to just to select the X and Y position, that's not correct, because the X and Y position is in the position of the mouse coordinates on the drawing canvas and not the drawing canvas coordinates. So the X position in the entire layout here is not exactly the X position in the drawing canvas. For example, the point 00, which is here, if we're clicking here at the top left of the drawing canvas, this is the 00 of the drawing canvas, but it's not the 00 of the layout, of course. So we need to convert this. If we click here, will be, let's take 50 by 100, so Y will be 50, X will be 100, for example, and if we click there, it should be converted to 00. It's pretty simple how to do that. You just take the X coordinate of where you click with the mouse and you subtract the left bounding box of the drawing canvas. So if we click there, we click this X coordinate and we subtract this little piece here, and we subtract this little piece here. So in theory that will move our drawing canvas virtually over there, which will work as well. But we have to do something. It's the pixel scale expression of the drawing canvas is a scale that will convert the coordinates of the object into coordinates of the drawing canvas. So due to scaling, for example, one pixel on the drawing canvas might appear as 2 pixels on the screen of your computer. So that's why you need to divide by the pixel scale. So finally we get an X and Y coordinates, and those 2 X and Y coordinates are the actual point inside the drawing canvas you have clicked, and from there on we can start a function, and that function is called here and this is a script action here, and we call the fill function, and we pass in the runtime, of course. Alright, and the scripts here are in a separate folder nowadays in construct 3, and we can just double click the script, and here we have the entire script, which I'll be explaining it to you. So let's get cracking. This is the fill function that we call at runtime, and we pass in the runtime. The runtime is like the entire context of your game when it's running, and it contains a lot of objects and variables you can access at runtime. And it also allows you to access all the variables you describe and all of the instances of the objects you put on your layout. So these objects here, you can access them, and also these variables, you can access them. So how is this done? The first thing we do is we make a local variable called C, and we pass it the first instance of the drawing canvas we find in our runtime. So the runtime contains an object called objects, and that's all of the things you can find on your layout. And then there's something called a drawing canvas. This is this object type here, the drawing canvas, and we get just the first instance. That's what we do here. So we get in this C variable, we get the instance of the drawing canvas, and from that drawing canvas we can do stuff. And then we have variable col for color, and for that variable we create an object with R, G, B and A variables in it. R stands for red, and we get this from the runtime.global_vars object, which actually defines all of the global variables you have in the event sheet right here, and the names of the attributes in that variable are exactly the same naming as you do in the global variables. So it has the R, the G, the B here. That's being obtained from the variables there. And as you remember, the RGB values here are set using the color sprite clicking here. So once you click the color sprite, those variables will be set, and that's the values you'll be picking up right here. And also the A for alpha, we just set it to a hexadecimal number, which is 255, which means full opacity, of course. So then we have a tolerance value called T, and we get that from also the global variables tolerance, which is here. And then this happens, from C, which is the drawing canvas, we get a function called getImagePixelData, and that will result in an object, an image data object, which is actually a standard JavaScript, called an image data object. And this syntax here then that's got something to do with a JavaScript principle called a promise. I'm not going to go too far into that. You can find that on the internet, what it is and how it works. But basically, once finished, we will get an object called D, and in this case, with getImagePixelData, this will be the image data obtained from the drawing canvas. And that implies the function here. This is of course a virtual function which we'll call floodfill with the image data. The color we just determined here, that's the color to be replaced actually. No, the colors to be filled, not the color to be replaced, but the color to be filled with. And then the X and the Y coordinates we've also determined in the event sheet. After we call floodfill, D will be updated, the image data will be updated, and then we just put the image data back into the drawing canvas. That's what we do here with load image pixel data. So effectively this gets it, the image pixel data, this will change it, and this will put it back. That's what happens here. So this floodfill function is a function we define ourselves here. But this logic, which I'll come back to in a minute, uses some helper functions, which is get color at pixel, set color at pixel, and color match. Let's start with the last one here. Color match will return true if the colors A and B match in a certain tolerance. And how do we do that? We just check if the R value of A, the red value of A, is between the red value of B. You can see that here, between red value of B, within a certain tolerance, minus t and plus t. So this is true, and then this ampersand means and, of course, in JavaScript, and the green value is between the green values and the tolerance, and the blue value is between the blue values and the tolerance, and the alpha value is between the alpha value and the tolerance. If all this is true, then this function will return true. So that's what the tolerance is for. So to give a practical example, for example, if the R value is 20 here, and the R value of B is 25, and the tolerance is 10, then it will be inside the tolerance, because 25 minus 5 is less than 10. So this is a color match function. But there's also a function to get the color of a pixel inside the image data. You have to know that inside the image data, it's a contiguous value of R, G, B, and A values. So a pixel is a set of 4 values in the image data. So let's do something like that. Let's give you an example. 7, 8, 9, 0, 4, 4, 5, 1, 5, 6, 6, 5, 8, for example. This would be 3 pixels, where 7, 8, and 9 are the RGB values, and A is the alpha value. This is the next pixel, 5, 5, 4, 1. This is the next pixel, 6, 6, 5, 8. Of course, now it's just single digit numbers, but you have to see it as a byte in memory, byte being 8 bits. So actually what you need to see here is that this number should be a number from 0 to 255, of course, which is a byte. So there's always a combination of 4 things here, and that's what we see here. How do we convert an x and y coordinate to a long string of image data, of byte data? Actually, if you wrap your mind around it, it would be not that hard. Just bear with me that it's a contiguous string of all bytes, and we convert the x and the y coordinate to a simple formula where we get the correct byte inside that long string, and we offset it by 0, 1, 2, 3 to get the R, G, B, and A values, basically. And there's also a set colored pixel, which is vice versa, of course. We do the same calculation here, and we set it to the red value, the green value, the blue value, and the alpha value. So those are the helper functions. Now we get to the bulk of what's going on here. And bear with me, I'm going to explain you how exactly that works. So this works using a principle called a stack, and a stack is like a deck of cards. When you put something on the stack and you do it again and again and again, if you get something from the stack, it's the last thing you put on the stack you get from it. The reverse thing of that is a queue, where like for example, if you're going to a supermarket, the first one to go into the queue is the first one to come out of it. It's the reverse principle of a stack, because in a stack, the last thing that goes into it is the first thing to come off. And in stacks, the principle is such that you can push something on a stack, and getting something off a stack is called popping. So what we do here in the function floatfill, we get the width, the height, and the data from the image data, and then there's a stack, which is basically just an array. A constant base color is the color of the pixel at x and y. So this is the color of where we clicked on the canvas. So usually it would be white. Every time I clicked in the beginning of the demonstration, it was a white pixel, so that would be the white pixel here in that. And then we have just a variable defined called operator, which will keep track of the current x and y position we're evaluating. So the first thing we do here is we see if the base color and the new color are the same, and if they are the same, we shouldn't do anything actually, and then we just return the function, and nothing will happen. So the color of the image data will stay unchanged. But if they are not matching, the function will continue, and then what we do is we push the X and the Y operator on the stack. So and then while the stack is filled, well, there is something in the stack. So while the length is greater than 0, that's what we do here. While the length is greater than 0, then we will execute this loop. So the first thing we do is we pop the first thing from the stack. The first thing this happens will make sure that the stack will be empty. And if there's no further filling of the stack in the rest of the function will just, the while loop will stop after that. But you can be guaranteed that it will be adding stuff to that, adding new coordinates to the stack. And that has 4 variables that lets the logic work as it does. So bear with me what it's going to do. So we start from the X and Y coordinate of the operator. And while the continuous up flag is set, which is true by default, and the Y operator is bigger or equal than 0. So while the flag is set and the Y operator is bigger than 0, we just decrease it by 1, so we go 1 pixel up, and then we set the contiguous up to whatever the color match function will return. So remember, the color match will return true if 2 colors match, and the color to match is the color at that current operator, which has just decreased its Y value here, and the base color. So what we say here is go 1 pixel up and check if the color is the same. If the color is the same, we set this to true, of course, becomes true, and then the while loop is still valid, as long as we are not on the top of the image. So again, the Y coordinate is bigger than 0 and it's still true. And this stops whenever we find a pixel which is not the same as the base color. Then this becomes false and the while operator stops. What will be the result? The result will be that the Y operator here will be the first pixel on the row where we clicked, which is the base color. So let me show you with an example. I've created an Excel example here. Let's fill this object, and where we clicked is the yellow pixel here. What will happen in this line 68 to 72 is we will start and we go, the Y coordinate decreases by 1. We check if the pixel is the same. It's also white, so yes, yes, again yes. But now the pixel is not contiguous anymore. So this is not the same color. So the operator will stop, and it will be here at the first pixel, which is to be changed actually. So then what we'll do, we move downwards while contiguous down is true, which is true by default, and the operator Y is smaller than the height. So we go down to the lowest part of the image while we're contiguous down. And let's carefully ignore this part for now. But what happened here is we set the pixel to the new color. So what happens is we set the new pixel to the new color, and let's do that. This becomes a new color. Operator Y increases. We go there and we say contiguous down. Is this the same as the base color? Yes, it's white. Let's set the pixel. And this is what we go here. And then if it's the same as the base color, yes. 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 The contiguous down becomes false because this is not the same as the base color, so the loop stops. If we were not to do this part here, this loop would stop and the end result would look like this, which is crap because it's not fulfilled, of course. So how do we go and fill all of the other pixels? Well, this is the magic here in this little thing where we use the stack. So while we're moving down here, we will check to the left and to the right of the pixel we're going down on. And whenever we find a pixel which is the same base color, where it used to be not the same base color, then we will add it to the stack. So that's what we do here. So we check to the left if the operator of the x minus 1, so this is x minus 1, and the colors match of the x, the color matches with the base color, which is true in this case, and the continuous left function is false, which is true, then we will set it to true. So we will negate this Boolean value, and we will push that here to the stack. So let's put an X in it. This has been pushed to the stack. And then we check to the right if it's the same color, but that's not the case. So we're not pushing it to the stack. So this will do nothing in this case. We go to the next loop in this while loop, the inner while loop here, and we go there. We set the color as we just saw, but while we're doing that, we're also checking to the left. And here we see it's the same base color. It's also white, but if you remember, we also check if not continuous left, and we just set the contiguous left Boolean to true. So this is nothing. Nothing is done with this. It's not pushed into the stack. The same happens here. Now this is true. Contiguous right is false, so we just push this one on the stack as well, and we go down. And then all of a sudden we come here, and then we check to the left side here as well, and then we see, okay, the value of the x minus 1 is it's not the same as the base color, so we come into the else branch of the if. Contiguous left is set to false. So when we're checking this, he checks this at the left hand side, and it says, okay, contiguous left is not okay. So this at this time, this Boolean is set to false again. And as we go down, we check this, we check this. All of a sudden we come here, and if you remember, it will actually be exactly the same as this result. The X will be the same matching color, white, and then this will have become false again, and you will get into this condition again, and you will again push that into the stack. So what will happen is this will also get pushed into the stack. So functionally, it just checks to the left and to the right every time, and when he finds a pixel in the base color, he will push it, and then he will no longer push things in the base color until sometime in the process of going down, he finds something which is not the base color. And then the first time, which is the base color again, he will push that one onto the stack as well. And then the next loop continues. So what will happen then? Then we come back, so we're fully down here. So this inner while loop is done. We come back to the outer while loop here, and we start from the next thing on the stack, which will be this one. So he will go up again, go up to here, and then go down again, and then he will all of a sudden find this one. He will put it into the stack and go down there, and that while loop is finished again. Then he found this one. He will go up, but he is already up, so then he will do that, and he will find this one, and he go down and down and down and down. Then he found this one, goes up, and he finds this one, X, and he does this one, and then he does this one, up, goes down, and all of a sudden he finds this one, and so on and so on. And then after everything is said and done, he will be flooding the entire thing here. So that's how it works. So that's the way he can do very complex figures and flood fill the entire thing. and then at the end of the while loop, everything is popped from the stack. The while loop will stop. Floodfill data will have its image data updated using the correct pixel information. That's it. That's the algorithm to floodfill the data using a JavaScript in Construct 3. So I hope you liked it. As always, please like and subscribe, and I will leave a link in the description where you can get the free template for the code which I've just described to you. See you next time.